You are given solid W, carry out the test below and infer accordingly. Take a spatula end full of W and put in a boiling tube. Add about 8 centimeters cube of water and shake. Keep the mixture for the tests below. So when you have this observation here, immediately after being asked you to add water, they want you to tell them or whether the solid dissolved or it did not dissolve, and if it dissolved, what was the color of the solution formed. So for this one, the solid dissolves, forming a colorless solution. So if a colorless solution is formed, it means that it is a soluble salt present. It is a soluble salt present, or because it is colorless, it means the colored ions are not there. So you can also infer by saying that Cu2 positive, which is green, copper 2 ions, which is blue, and ion 3 are absent, because this one is brown, blue, and green, so they are not there. So this one is okay, this one is also okay. To about 2 centimeters of solution of W, add sodium hydroxide, dropwise still in excess. White PPT soluble in excess. So that shows you that the amphoteric, they are the ZAP, zinc ions, aluminium ions, and the lead ions. So you start with zinc, 2 positive, aluminium, 3 positive, and lead, 2 positive. They are present. To about 2 centimeters cube of solution W, add ammonia solution, dropwise till in excess. So a white precipitate, white PPT precipitate, insoluble, which does not dissolve in excess, insoluble in excess. So if it is insoluble, then aluminium and lead are present. If it is soluble in excess, we are putting ammonia solution, the white precipitate dissolve, which dissolve in excess to form a colorless solution. It means zinc is present. But now, since zinc is absent, what is present is aluminium and lead. Other ions which I like it to be here is barium, magnesium. You can include them there, but here when we start they were not there, so it is important you don't include them. You only include the 2 which are there. Here there were no magnesium, there was no barium, so we don't include them. Add about 2 centimeters cube of solution W to about 2 centimeters cube of solution W. Add about 5 drops of nitric acid, followed by 2 drops of barium chloride or barium nitrate. So the first thing we expect here is effervescence or no effervescence, because here we are adding acid to a solution. Whenever you are adding an acid to a solution or to a solid, the first observation is effervescence occurs or it does not occur. So when we are adding nitric acid to this solution, we expect effervescence. But for this case, there was no effervescence, no effervescence. You don't have to infer. That's the observation you have made. There was no effervescence because you expected effervescence, and then no white PPT because we expected a white precipitate to form with barium ions. So if there is no white PPT, it simply means that the sulfate ions were absent. Now the question most people ask is that the sulfite, the carbonate, forms a white precipitate with barium. Barium sulfite is a white precipitate. Barium carbonate is a white precipitate. Why didn't we include it here and say this and this or these three are absent? So if they were present, we could see effervescence, right? So if there is no effervescence, it means this and this, they are absent. And then there is no white PPT. If there was a white PPT, then as sulfate ions are present. So I hope you have understood that. There is a version of this equation, a different version that says like this. To the fourth portion, or whichever portion, add a few drops of barium nitrate. Now, in this case, we are starting with barium. The other question was starting with the acid and then adding barium later. So that is a simple trick which you are supposed to know. So add a few drops of barium nitrate and then followed by nitric, 5 centimeters of nitric acid. So here we expect two observations. Here a white PPT is formed because we are adding barium nitrate. If there is a sulfate, a carbonate, and inside there, a white PPT is formed. A white PPT is formed, and then what happens when the acid is added? A white PPT is formed insoluble in the acid. It means that the white PPT remains. The white PPT does not dissolve to form a colorless solution. So that simply confirms that it is the sulfate 2- is present. Another observation we expect from the same is a white PPT, white precipitate, soluble in the acid, to form a colorless solution, soluble in the acid to form a colorless solution. So if that happens, it means here inside there was a carbonate and a sulfite. Because a sulfite and a carbonate, they will undergo neutralization to form a colorless solution. So if this happens, then the sulfite 3 and the carbonate are present, right? So you see, this is the only simple trick KCSE comes with, and then you find people failing. So when they start with a nitric acid, the nitric acid, if there is a carbonate inside, it will react. So let me give a different version also of the same question. This time effervescence occurs, and a white PPT is formed. We are adding barium, we are adding nitric acid, and then followed by 2 drops of barium nitrate or barium chloride. This and this, it works in the same manner. So if effervescence occurs and then a white precipitate is formed after adding barium, so what does that tell you? The acid react inside there was a carbonate or a sulfate. There was a carbonate or a sulfite, 3 and 3, right? So when the acid is added, it reacts with the carbonate or the sulfite producing a carbon dioxide and the effervescence occurs. So it means the reaction is already over. There is no more carbonate, there is no more sulfite. Yes. Now when you add barium 2 drops and then a white PPT is formed, it means that this one is no, you don't include it. You don't. Why? Because it reacted with the nitric acid forming and the reaction was over. So therefore white PPT confirms that SO4 2 is present. Is that clear, my good student? Thank you. Another quick reminder I want to remind you is about when we are adding sodium hydroxide dropwise until in excess. Here we expect 3 observations because it is either the first observation will be there or the second or the third. So here, when a white precipitate PPT is formed, which dissolve in excess, sodium hydroxide. So a white PPT is formed and then the white PPT dissolves in excess. It means it is up, like I have told you, it is up. The zinc, the aluminium, and the lead, they are present. So that's one observation we expect. It will be either this or the second or the third. So let us go to the second observation when you are using sodium hydroxide. White PPT is formed, which does not dissolve in excess. We are using sodium hydroxide, excess sodium hydroxide. So if it is a white PPT is formed and it is insoluble in excess, it simply means that barium, that magnesium, and the calcium are present. It means that the zinc, the aluminium, and this is absent. But we want to talk what is to put or to infer what is present only. These ones are absent, therefore this one is present. The third observation you expect on the same is that no white PPT, no white precipitate. So if there is no white PPT, what is the inference? The inference is that sodium ion, potassium ion, and ammonium ion is present. Is there a reason for you to fail? Because sodium hydroxide is something which will always be there. Ammonia solution. So we have finished with sodium hydroxide. You have all the marks with you. Fail at your own will. To the second portion, add ammonia solution. Whenever we are adding ammonia solution, the ammonia solution you will find it written as ammonium hydroxide. In that small bottle, reagent bottle, you will find it written ammonium hydroxide or ammonia solution. So we are adding ammonia dropwise until in excess. We expect 3 observations. The first one is that a white PPT, we are adding ammonia. Remember, what is important is to master the reagent you are adding. Now we are adding ammonia, not sodium hydroxide. Ammonia solution. A white PPT is formed, soluble. A white PPT is soluble in excess. In other words, what I'm saying is that a white precipitate is formed, which dissolve in excess to form a colorless solution. This statement means what I have said. This statement means a white precipitate is formed, which dissolve in excess to form a colorless solution. So if that is the case, a white PPT is formed and then it dissolves in excess, then it confirms that the zinc 2 ions are present. Because this is the confirmation for zinc ions. Ammonia will dissolve to form a white precipitate and then dissolve in excess, zinc ions are present. Observation number 1. Number 2, white PPT insoluble. Insoluble meaning that it does not dissolve in excess. Insoluble in excess. Ammonia solution. A white PPT insoluble in excess, meaning that a white precipitate is formed which does not dissolve to form a color. So it means the white precipitate will remain after adding in excess. So what is the inference? It means that barium, 2 ions, magnesium, 2 ions are present. So I have left out calcium. For the other one, we were using calcium, but for sodium hydroxide, for ammonia, I have left out calcium intentionally. State these two and you get your marks. The last observation is that no white PPT. If there is no white precipitate and you are adding ammonia solution dropwise in excess, so here so there's no white PPT in drops and in excess. There is no white PPT in drops and in excess. So that simply means that sodium, potassium are present. They are present. I have left out ammonia. I have left out ammonium ion. To the third portion, add 3 drops of lead to nitrate. Whenever we are adding lead nitrate, we expect 2 observations. Lead nitrate, we expect 2 observations. White PPT. If a white PPT is formed and you are adding lead, it means the sulfate, the sulfite, the carbonate, and the chloride are present. Because all of these, they form a white precipitate with lead.